everyone, welcome to Physics by Aryan. I'm very happy to welcome you all. So we are doing our free foundation physics course. The purpose of this course, as you know, is to make sure that you have a very strong basics. All the basic information starting from basic mathematics, graphs, up to mechanics and electronics, all the basic requirements that you have in order to do a very good preparation for competitive exams. In the 15-day lecture series, I am covering it all. So today, in our fourth topic, we are going to cover Taylor series. Now, Taylor series is going to be a small topic. I have already shared the notes on my website and an app. You can go to website and an app, and you should read those digital notes after this class, because those notes involve many solved examples and all the details in a well printed format. That will actually help you in gaining a more good perspective and making your concepts very strong. So let's begin. So what is Taylor series? So Taylor was a name of a mathematician. So whenever we expand our functions, so let's say we have some function with us, and many times what we need is we want to expand that function in terms of polynomials. So what is basically polynomials? So polynomials are, for example, x square or x plus 1 square, x minus 1 cube. These kind of things or these kind of mathematical terms are known as polynomials. So we want to expand our function in terms of polynomials. So in order to expand the function, you have to decide two things. Number one, what is the function that you want to expand? So let's say we want to expand fx. F is a function of x, and what is a point around which you want to expand? So we want to expand this function around x equals to a. So these are the two basic things that you should know about the Taylor series. So what will be the expansion of fx around x equals to a? So fx will be equals to f of a plus f dash a divided by 1 factorial. 1 factorial is 1, so nothing to be changed here. F dash a means derivate fx one time, so do differentiation one time and then put x equals to a. Okay, multiply by x minus a plus f double dash a divided by 2 factorial. So what does f double dash a means? That derivate your function 2 times and then put x equals to a. Okay, this is the meaning of f double dash a. Multiply by x minus a square and so on. So this series will keep on going. So this is the definition of Taylor series around x equals to a point. So now let me just give you one example so that you get a very good idea. So the example is you want to expand fx equals to 1 by x around x equals to minus 1. So what is the definition here? So first of all, we need to find f of a. And what is my a? A is equals to minus 1. So I will put the value of a in my function. So if I put 1 here, minus 1 here, what will I get? 1 divided by minus 1, which is minus 1. So this is your f of a. Now I will do f dash x. I will take a differentiation one time. So if I differentiate 1 by x, I will get 1 by x square. And now I will put the value of my a here. So I will get minus 1 whole square. Again, I will get minus 1. So you have to differentiate it and then put a value of a. Now again differentiate it. So if I do one more differentiation, I will get 2 by x cube. And if I put a value of minus 1 here, I will get minus 2 by x, minus 2, simply minus 2. Okay, now if I do triple derivative, what will I get? I will get minus 6 by x4. And if I put minus 1 here, I will get minus 6 by 1, which is minus 6. So up to 3 or 4 terms, it is enough. So now I have got 3 or 4 terms. So now what is my series expansion? So my series expansion is f of x equals to f of a plus f dash a into x minus a plus f double dash a into x minus a whole square divided by 2 factorial and so on. So let's just start putting the value. So my f of x is 1 by x. My f of a is minus 1. So let's put minus 1 here. My f dash a is again minus 1. So let's put value of minus 1 here into x minus a plus what is my f double dash x a? It is minus 2. So let's put minus 2 here and multiply by x minus a whole square. Now let's go to third. What is my f triple dash x? It will be minus 6 divided by 3 factorial into x minus a whole cube and so on. So your function will keep on going. Your series will be keep on going on. So what you can write finally is minus 1 minus of x minus a minus of x minus a whole square minus of x minus a whole cube and so on. Because 3 factorial is also 6. So 6 and 6 will get cancelled out and you will get something like this. Okay. So this is your series expansion. So you can expand your 1 by x in terms of the given polynomials. Okay. Now, this was a Taylor series. There is one more term known as Maclaurin series. So what is Maclaurin series? So when I expand my function around x equals to 0, so now the point around which I am expanding is 0. Then the Taylor series is known as Maclaurin series. It's nothing more. The formula is same. The only thing is whenever you expand around x equals to 0, you get a Maclaurin series. So now let's do this example as well. So there is one example that I want to expand sine pi x. So again, my point is x equals to 0. So f of 0 is 0. Now I take a derivative. So f dash x will be pi cos pi x. And if I put the value 0, I will get pi. Then f double dash x is minus pi square sine pi x. And if I put a value of 0, I will get again 0. Then my third derivative will be minus pi cube cos pi x. And if I do put value of 0, I will get minus pi cube. And you can keep on going like this. You will get 0, pi, 0, minus pi cube, and so on. You can keep on going like this. So what will be your Taylor series then? F of x equals to f of 0. So f of 0 is 0 plus f dash 0 is pi multiply by x. Because now, so what I should write is actually x minus 0 because it is x minus a, right? And a is 0 now. So I can simply write this plus. Now again your f double dash 0 is 0. Then your f triple dash x is pi cube divided by 3 factorial into x minus 0 whole cube. And you can keep on going like this. So what you will get is pi x minus pi cube by 6 x cube plus so on, so on, so on. So this is your series expansion of the sine pi x. I hope that you have understood the concept that how to expand the functions in using the Taylor series expansion. So this is a short lecture. I am not extending this lecture much because there is no need to extend beyond this. I have given many examples in my notes, so you can go to the notes and use the same rule to solve all other problems. So those examples are solved ones. So wherever you get stuck, you can actually look at the solution. And also in the end, there is a detailed exercise which you can do by yourself, and answer keys are given there. So you can match your answers as well. So best of luck. This was a small lecture. See you in the next class in which I will be teaching you Jacobian.